Have you ever wondered why water can pile up on a penny without immediately spilling off? Today we're going to explain that using intermolecular forces, also called IMFs.
Intermolecular forces are attractions between molecules that affect properties like surface tension, boiling point, and evaporation.
Our demonstration focuses on surface tension and how hydrogen bonding makes water behave differently than many other liquids.
To help explain IMFs, we have made this model. Think of intermolecular forces as different levels of stickiness between molecules.
First, we have London dispersion forces. They're like Scotch tape. They are the weakest intermolecular force, and they are found in all molecules.
Dipole-dipole forces are like duct tape. They're stronger because polar molecules have positive and negative charges that attract each other. Think of it like a magnet. The negative and the positive end is connecting, which is in polar molecules, which makes it stronger than the Scotch tape above.
Hydrogen bonding is like superglue. It's the strongest intermolecular force we're studying, and it's what holds water molecules together so strongly.
As intermolecular forces get stronger, molecules stick together more tightly. The most important step in a chemistry experiment before we start is going to be safety. So a few basic tips you can remember is always wear closed-toed shoes, put your hair up if it's long, roll your sleeves up or wear short sleeves, and wear safety goggles at all times. Our experiment today, we're not dealing with any harsh chemicals, but in many classes like AP Chemistry you will, so it's very important that we're safe. Right now, we're going to start the experiment. So, I'm going to use this pipette to see how many drops of water we can fit on the penny before it spills. When I'm doing this, I want you guys to pay attention to what shape the water makes and how it spills off. Alright, so we can just get in here. We're going to count these one at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So look at the shape real quick. You see how it's forming a dome shape instead of just spilling off right away? This is because of the IMFs and the hydrogen bonding acting, which holds the water molecules together. "21, 22, 23, 24, 25, 26, 27, 28. Pay attention how the shape is still a big dome shape. It's not spreading off like it looks like it should.
It's getting more vertical.
29, 30, 31, 32, 33. So it's gonna, I think my prediction is that it's gonna break somewhat soon, but look at this shape. These hydrogen bonds and these IMFs are really strong. 34, 35, 36, 37, 38, 39, 40, 41, 42. 42 drops.
And then it spilled. This happens because water molecules are connected by hydrogen bonds.
Hydrogen bonds cause water molecules to pull toward each other. This attraction creates surface tension.
Surface tension makes the surface of the water act like a stretched sheet or skin. That's why the water can hold together in a dome shape before gravity finally causes it to spill.
Imagine a group of friends holding hands. If they're barely touching, it's very easy to pull their hands apart. That's like LDFs, they're very weak. If you're holding hands tightly, that's like the dipole-dipole forces, which are stronger than LDFs, but still not super strong. And if they're locked really tightly and really strong, that's like hydrogen bonding, which is what we just saw on the penny. The stronger the intermolecular force, the stronger the attraction between the molecules.
Now that we've seen how many drops of plain water fit on a penny, let's see what happens when we add dish soap. Always remember though, be safe. Be safe in the chemistry lab. Okay, I'm gonna take a little bit of soap on my finger here, and I'm gonna rub it on the surface of the penny like this. Okay. Our prediction is that fewer drops of water will fit because the soap will change the intermolecular forces between the water molecules on the penny.
Remember before we got about 40 drops of water to fit.
One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Notice how the dome shape didn't form there, and the water, instead of rising up, it spread out thinly. Without soap, the strong hydrogen bonds allow the water to build a large dome on the penny because of the hydrogen bonding present. With soap added to the top of the penny, the hydrogen bonding attractions become weaker, which creates the surface tension we saw.
That shows how intermolecular forces directly affect surface tension. Stronger intermolecular forces create stronger surface tension, while weaker intermolecular forces create weaker surface tension.
A student might ask, why does soap change it? To answer that question, soap molecules get between the water molecules and interfere with the hydrogen bonding. When hydrogen bonding is weakened, surface tension decreases and the water spreads out more easily.
Another question that many students ask is how do other liquids work? And to that we say many different liquids, in fact all liquids, have different intermolecular forces present. For example, water like we use has very strong hydrogen bonding because of its chemical compound H2O, while other liquids have weaker attractions. Liquids with weaker intermolecular forces usually have lower surface tension and will not form as large of a dome like we saw.
Our demonstration showed how intermolecular forces affect the behavior of liquids.
Hydrogen bonding creates strong attractions between water molecules.
These attractions create surface tension, allowing water to build up on a penny and form a dome. Thank you for watching.